Hi, I'm Lydia.
And I'm Heather.
And this is our fourth quarter ISP entitled Sweet Stacks. Alright, first off with our problem. Our problem in this is how do varying sugar substitutes, we used 3 different substitutes, and then our regular sugar, how do their compositions affect layering liquids according to density? Alright, our purpose was that it has been proven that a rainbow effect will be caused when we mix different amounts of sugar with different amounts of water and food coloring. We used a layering by picking up with a straw to create the different layers, and we had 5 different chemistry concepts within this. First of all, an aqueous solution was created. Second of all, our solvent was our water, so it represented a solvent, and then also our solute was the sugar or sweetener that we used in each one. Also, we had homogeneous and heterogeneous mixtures, and we wanted to see how evenly dispersed they were through that. And our other one was that the straw manipulated the air pressure within it and made the outside air pressure higher than the inside, and capillary action kept the liquid in place. So all of that represented capillary action. A little bit about each of the different sugar substitutes that we used besides the granulated sugar was that Splenda was our first, and it is composed of sucralose, that's what it derives from, and it's used in baking, and it can be for hot and cold temperatures, so that's something that's a really great feature of that. And we also have Truvia, which derives from stevia, and that's a bush with leaves of up to 300 times the sweetness of just regular sugar. And then lastly, we used Sweet and Low, which is saccharin, and that is the oldest sweetener. Alright, with our hypothesis for this was that if Splenda is added to water, then it will produce the most distinct even layers, since it has the most stable composition at all water temperatures, as I said up above in the purpose, that it can be used in hot and cold temperatures, and that it will distribute most evenly in the water. And we really thought that because it had more defined, kind of finer pieces, and so that would allow it to distribute more evenly. With our materials, just picking out some really important ones that we used was the different types of food coloring, the 4 different types, and those were the red, yellow, green, and blue. And also using a clear straw was a really important detail of that, because it allowed us to really see the layerings of liquids and the colors a lot better. Also for each trial we used 1.5 cups of water per cup per trial. So those were all really important things in our material section. Onto the procedure. First of all, we gathered all of the materials that we needed. We gathered everything that I had talked about in the materials section, plus, you know, all of the different sugars, everything like that. We gathered all that together. Then in our second step of our procedure, we made observations of the sugar, noting it in our data table. We kind of looked at the different compositions, the different textures, kind of what they looked like, and you'll see that later in our results. And our third step was that we labeled the cups 1 through 4. Just we have the different cups right there labeled. Fourth of all, we filled the cups with lukewarm water, placing the same amount in each glass, as I said earlier, 1.5 cups. So we placed that in the water. And then in our 5th step, we placed 4 drops of food coloring in each glass, and of course the different colors and so on. And we used the darker colors for the higher numbered as we go along. So as you can see, it kind of goes from light to dark in the colors there. And then our 6th step, we put 1 spoonful of granulated sugar into the glass labeled 1, and then for the other 3 we did the exact same, but adding the amount of spoonfuls in relation to the amount of the number that it was labeled at, such as cup 4 receiving 4 tablespoons. Seventh, we mixed the sugar until it was dissolved, stirring with a spoon or a straw, and we just used a straw for that, just to make sure that everything was dissolved and we could see it all clearly. And then our 8th step and our 9th step here, for our 8th step, we place the tip of the straw into cup 1, pressing our finger down using the capillary action. And it would obtain the water, and we wanted to make sure we used this special technique of releasing and pressing down at the right time so that we didn't lose any of the substance from that. And then for the step 9, also kind of shown here, it just says that we would use the same technique for every single one using that special technique. And then 10, we recorded our observations and we repeated for all of the different sugar substitutes to get the best results.
Okay, so moving on to our results, basically what we did was we took observations before the reaction and after the reaction, or before the rainbow and after the rainbow. So for each substance, before the reaction, we started with granulated sugar, which is the original household product, and we noted that it was white with defined particles, grainy, it wasn't very fluffy, and it had little crystal-like particles to it. We then moved on to Truvia. It was white with defined particles as well. It was a little more fluffy than the granulated sugar, so we noted that. And then we moved on to Sweet and Low, which was the fluffiest of all of them. It was very powdery and it wasn't as defined as the others, so therefore it ended up dissolving fairly quickly. Splenda was white. It was a snow-like. It was powdery as well, but not as powdery as the Sweet and Low. It was very light and defined, but not as much as the others. So after the reaction, we noted how quickly, like what they did in each of the layers, and also we noted how quickly they dissolved. So for granulated sugar, it dissolved fairly quickly with little stirring, and it created very distinct layers, just as it was supposed to do. We moved on to Truvia. This one took a little longer to dissolve, but it also produced distinct layers in the straw. The Sweet and Low dissolved fairly quick as well. There's little stirring required, and the layers were still distinct and clear. Lastly, we had Splenda. It dissolved instantly, and it kind of fizzed like a carbonated beverage whenever it did so. But strangely enough, it produced the least distinct layers. And in the picture here, you can kind of tell that they're slightly blended together, and we don't know how that happened. It was kind of the outlier in the experiment. So moving on to our analysis. The data found above shows that really the composition of a substance doesn't have to do, like it doesn't affect its layering and the density. Whenever we did the granulated sugar, it was the original, and though it dissolved rather quickly. Therefore, the layers in it were distinct and defined, just as it was supposed to do. Truvia was the same way. It was white, more fluffy. It did take a little more effort to stir, but the layers were still distinct and well defined. The Sweet and Low was the most fluffy, as I mentioned before, and it dissolved fairly quickly as well. The layers were distinct. It did what it was supposed to do. Splenda was the outlier in this. It was a little more grainy. It dissolved instantly, unlike the others. It was the most unclear. The layers are still there, but they're blended together, which is a little strange. The only main reaction we had going on was the sugar or the sugar substitute being dissolved into the solvent water. The sugar and sugar substitutes acting as the solute again. They all dissolved fairly easy and in the same manner, except for the Splenda fizzing. Another solute was the food coloring that was not mentioned before, but it acted more as a constant, so it had no effect on the results of the experiment. The reason why this worked was because the law of density states that really layers will layer based on their weight. The heaviest will be on the bottom, the least heaviest will stack on top of that, and they'll go in ascending order. We found through this experiment that composition really doesn't have any effect on density and its layering in a straw. So further experimenting could be done as to see why Splenda was not working as it was supposed to, why it was slightly different, but that could have been that was also a limitation that we listed later on. Some observations at the end, we noticed that the rainbows we created were heterogeneous when they were in the straw because they were not evenly dispersed and they were in distinct layers. But before they were in the rainbow, they were homogeneous in their distinct cups because they were the same color throughout and evenly mixed. Capillary action was used in this reaction whenever we used the straw to hold each layer in place. And the imbalanced air pressure kept the liquid solid where it was supposed to be so that we could take pictures and make observations. So moving on to our conclusion, our hypothesis was not supported because the law of density states that composition really doesn't have an effect, and as this experiment showed, it doesn't. For the most part, Splenda could be the outlier in this. Our new hypothesis would be that if layers are stacked by weight, the heaviest is always going to be on bottom, and as the other liquids are poured on top, they will stack according to their each respective weights. Moving on to our limitations in this experiment. Most of the limitations were just our errors. We used the same cups in this experiment. There could have been some mixing of the sugars that were in or the food coloring contaminated cups. One time we actually made a mishap and dropped the liquid we had in the straw into one of the other cups. That could have been a reason why Splenda didn't work. And originally our experiment was a rainbow in a cup, and this one could also be used as another experiment if it could be done correctly, but we're going to count this as a limitation because we couldn't get the liquids to layer on top of each other. We had to pour down a spoon, and it just really didn't work out, and it may have been the types of materials we were using. But that was one of our limitations. Another limitation was that, another limitation is that we use some mixing of the materials. To improve this experiment, we would say that you could find the exact densities of each of the sugars and really have a more mathematical, direct, like have your numbers and have a very distinct density for each of them, using separate cups and maybe making sure that there's not as much room for cross-contamination. Lastly, another experiment that could be done is going right to Splenda and seeing specifically why it did not act as clearly as the other ones did. So this was our experiment, Sweet Stacks. Thank you for watching.